Like histograms, box plots or box and whisker plots offer another way to evaluate how sets of numeric variables are distributed. In the case of box plots, emphasis is put on quantiles of the data, with the bounds of the boxes generally representing the first and third quartiles, and the lines or whiskers extending to the minimum and maximum values in the data set, except in cases when outlier values are identified, which can then be represented with points outside of the remaining range of values. Creating a basic box plot for a single set of values is easy with the box plot function. Let's create a set of values first. We'll use the rnorm function to generate 50 random variables with mean 0 and standard deviation 1, just like we did in the histogram video, and assign the 50 values to the object rand50. We can then pass this rand50 object to the box plot function, and we get a box plot with a median indicated with a dark black line near 0, the first and third quartiles represented by the lower and upper bounds of the box, and the range of values indicated with the lines extending from the box. In this set of random variables, the algorithm for identifying outliers identified a single outlier indicated with a point at the bottom. This is a start, but what if you wanted to compare two distributions to each other? Let's create a second set of random variables. We'll call it rand50b, and this one will have a mean of 1 and a standard deviation of 2. Now, we have two separate vectors, rand50 and rand50b, each of length 50. From here, there are several ways we can plot side-by-side box plots, one for each vector. The first is to pass a single set of numeric variables to the box plot function. We'll first concatenate these two vectors together with the c function and assign the result, a vector of length 100, as the object cvec100. Of course, just passing this to the box plot function would give a single box plot based on all 100 values. Instead, we can take advantage of the formula notation indicated by the tilde to plot these according to a grouping variable, which we'll create now. We know that the first 50 values in cvec100 are from the first data set, rand50, and the last 50 from rand50b. And so we'll create a new character vector of length 100 that stores grouping variables corresponding to each of the 100 values in cvec100. I'll call this new object group, and we'll use the rep function to combine 50 A's and 50 B's. Now I can use the tilde notation, which in this case can be read as create a box plot of cvec100 by group, and we get box plots for the two separate groups side by side. An alternative is to create a list that stores the two data sets. I'll do that here with list A equals rand50, comma, B equals rand50b, assigning the list as the object rand_list, and then pass this list to the box plot function, giving us a similar plot as before. Of course, both of these approaches can be easily extended to more than two groups. One important argument that's unique to box plots is the range argument. This essentially defines how outlier values are determined. By default, range is set to 1.5, which means the lines extending from the box will only go as far as 1.5 times the inner quartile range from the box. Values exceeding this limit are represented as points. For example, extending this to 3 causes the lines on both plots to include all values in the data sets. In contrast, dropping it to 1 causes additional points to be represented separately as points. If you want to ensure the lines go to the extremes of your data and not include any outlier points, you can simply set the range argument to 0. As with other plot types we've looked at, we'll cover some other customizations that apply to multiple plot types in a separate video.